Hello world and welcome back to Money Makes Games. Now, if you've been following this series, this is the second episode in my beginner series on how to create a Pong-ish game. If you're ready to go ahead, then come with me. My name is Moni and I make games. Now, before I go on to actually give my ball some physics properties and allow it to get launched, we're going to look at something. Remember, in the previous lesson, we set up our friction for our ball. Now, you might think that friction is going to slow down the ball as in normal circumstances where we have air friction, so that if you throw something, it slows down because the air is pushing against it. But Unity doesn't have air friction. So if you look at this, the friction set to 0.4, our ball starts to bounce eventually. And you'll see it just starts going a little higher and a little higher every time because we've got perfect collisions. Now, let's push that friction up really high. Let's make it 8. That makes no difference. That's because the friction only applies when one collider actually touches another collider. So because there's no real air here, there's nothing to apply friction to the ball, and therefore it doesn't affect its speed. The only place the friction gets affected is right here when they're touched. And because they're not actually trying to move parallel to each other, there's no effect. So yeah, just keep that in mind when you do physics in Unity. Right, now, so if we look at our game design document, we know that our ball needs to be able to basically launch itself in a direction. And we also know that it needs to be able to start in front of a player or at a specific position. So let's work on that. Firstly, let's grab our ball over here. We can minimize these like this, just to make things a little easier to follow. And we'll go add component. And let's just keep it simple and call this ball. Okay, that's going to create a script for a mono behavior, which is basically just one of these things that attaches to your game object. And in that script, we can define what the ball should be able to do. We've already gotten a lot of stuff free with Unity's physics and the colliders and stuff. So we just need to do a little bit more work. Over here, we can go like this. We just say edit script, but before I do, I'm going to click on my assets, and I see that the script was actually created in the root of my assets folder. I don't like that. I want a folder for my script, so we'll go folder, say scripts, whoops. There we go. I've got a scripts folder and just move it in here. While Unity is reloading, I want to talk to you about why I'm doing it this way. Why am I doing this painstakingly slow way of showing you how to make a game? Well, firstly, when you're just starting out, there's a lot of stuff you're unsure of, and sometimes it's the little stuff that gets you and you don't know how to get around it. So I thought, I'd show you step by step. I also want to show you that even though it looks very impressive when guys on YouTube do their scripts and just punch out code and everything looks great, a lot of times behind the scenes there's struggles where people get stuff wrong, like doing a physics material instead of physics material 2D, or you get stuck on a problem for hours. And if you don't know that when you're beginning, you can get frustrated and think, I'm terrible at this, I'm never gonna make it. I want to tell you that everybody struggles. So, just stick with it. And, if you're really stuck and you haven't gotten anything done in an hour, go online. There's lots of great communities. If you go to the Unity forums, you can go to Stack Overflow. These days, you can even ask ChatGPT to help you. But keep moving forward and just don't quit. It gets easier. Okay, so I've double-clicked my script and Visual Studio is slowly starting to load it for me. As soon as it's loaded, we're going to get into it. Now, we want to get to the rigid body on our game object because that is where we can apply a force to it to start moving it. We also want to modify its transform. So let's have a look at how we do this. In Unity, if you have a mono behavior, you can get the rigid body in two different ways. First, let's declare our rigid body. We say rigid body, and here we go 2D. There we go. Visual Studio is catching up. It should autocomplete for you to help you out there. And we'll call that RB. Now you'll see I'm adding a little underscore to this variable name. That's basically just a naming convention that I use, and I think there are standards that you can look up. There's different people use different standards, but for me, I'm going to use an underscore to denote a variable that is at the top level of my class. If I use a variable inside my function, it's also going to be a lowercase variable, but I'll know that it's been declared in this function. It just makes it easier to look stuff up later on. And if it's going to be a public variable, which other classes can see, then I will give it a capital letter there. That just basically tells you a little bit about your variable. So if you look at your code five months down the line and you don't know where you declare that variable, at least you'll have a clue of where to look. Okay, now the first way we could get our rigid body is to declare it up here, and then we can just go RB equals get component, and here you go like that, and you go rigid body 2D. So what this function basically does is it looks for a rigid body 2D. Oh, I really stuffed that up, didn't I? It looks for a rigid body 2D on your game object and then assigns it to this variable. The other way I could have done this is by basically just going serialized field, and now what this does is it creates a field in the inspector where you can actually drag the rigid body to assign it. So let's save. I press Ctrl S and I go back to Unity. After it's done rebuilding, we'll click on our ball. There we go. That took a little while. Now you see it's got a field here for RB. Notice how Unity automatically just makes that capital letters. And we can grab our rigid body from there and just put it in there. These are two different approaches. The serialized field one is probably safer than looking for the component, because then you can already confirm that it's there when you're building your game. So there's no surprises when you click run. Okay, but it's up to you. There's different ways of doing things. So we've got our rigid body. Now we also want to add a force to it. So we'll serialize a field. We'll make that a data type called float. And we will call that force size. Or we could probably call that magnitude. Okay, so this is going to be how hard we're going to fling our ball in a direction when we launch it. Next, we're going to have to determine which direction we want to launch our ball in. Now, for now, I think we're just going to launch the ball up by a little bit and see what happens. So we'll go vector 2, direction, whoops. And we'll make it vector 2 dot up. Now let's take a moment here to talk about this. Vector 2 dot up is a shortcut way of saying that we're creating a vector which has an up direction. In other words, for every unit that we move one up, we are moving 0 to the left or right, so that's straight up. If I was going vector 2 dot right, that would mean going 1 unit to the right, but 0 units up or down. If I want to specify a direction, we could do something like that. So that's new vector 2. And let's say we want to shoot our ball up 45 degrees. So that would be for every step right that we take 1 step upwards. If we had a -1 here, which way do you think we would be going? That's right, we'd be going 45 degrees down. And if we make the x a minus, that means we'll actually be going down and to the left 45 degrees. Okay, for now, let's do 45 degrees up. And just to test this out, we're going to go rigid body dot add force. And now the force we're going to add is going to need a direction and a size. So we take the direction, which we call direction here, and we multiply it by how hard we want to throw the ball. So we'll use force magnitude there. And that's it. Now I'm putting this in start. start is what they would call a unity message. So on each frame, that's basically each loop that the game runs, it's going to call certain things. So in the beginning, on your first or your second frame, that it's going to call start. Before that, it's going to call awake. And then finally, in every frame, it's going to call update. Now, this is very simplified, but basically that means that you'll get one awake, you'll get one start, but you'll get an update on each frame. What I would suggest is that you look at the documentation for the Unity game object lifecycle, which I'll include in the description if you really want to know more about this. For now, all you need to know is start happens once, update happens every frame. Okay, so we've got our rigid body, and at the very beginning we're going to add this force to it. Now let's save and go back to our inspector. There we go. As you can see, this takes a little bit of time every time. Okay, now, right now, our force magnitude is 0, which means that no force at all is going to be applied to our ball. So let's create a little bit of a force. Let's make this 10 and see what it does for us. We're going to play. Okay, the force was very small and you can barely see the effect, but the fact that our ball is now not just moving straight up and down but slightly sideways should tell you that a force was applied. Now let's make our force bigger. Let's really exaggerate it. Let's make it 500. And as you can see, the ball immediately flies away. Alright, so now we've managed to launch our ball. We've managed to make it bounce off the pedal. And we will later on also let it actually spawn in front of the player. But for now, let's keep it inside our game area. So how do we do that? Well, we make the ball bounce off the sides, of course. So let's zoom out a little bit here. And I'm just going to create an empty game object. And we'll call this wall top. Now this is going to be an invisible wall. We'll put it here, and then we will add a collider. We'll go box collider 2D. Now right now I can't see the collider to edit it because, there we go, it's not that small. But if it was too small, you could go here and actually change the side of your collider and the offset for it over here to move it around. Just good to know. But now let's grab this. Okay, we've got that. And then, because we also want to collide at the bottom, we'll go select it over here in the hierarchy. We'll go Control D, and then we move it all the way down. Match that up. So that should stop the ball from bouncing out of the scene at the top and bottom. Now on the sides, we want the ball to be able to exit because obviously we want the players to score. So later on we'll put colliders there, but we will do something special with our colliders. We'll make them triggers. So what's a trigger? Well, a trigger is basically like a collider, but instead of the ball bouncing off it or registering a hit, it just says, okay, I just hit this, and moves on as if nothing has happened. That's called an on-trigger enter event. So let's implement that just quickly so we know that we went through a trigger. We go down here. Now Unity is going to help you out here. There we go. We've got on trigger enter 2D. If you select that, then you've got your on trigger, and what happens is if the ball actually hits a trigger, it's going to register an event here and tell you which collider it hit. Now let's just do a little something. I'm going to do debug.log. Now this is basically a way for you to see what's happening. So you're logging an event, you can log errors, and you can log warnings as well. We're just going to use normal debug.log right now, and we'll say ball just entered and then we'll get collision.name. Now collision is the collider 2D on the other object, and the name would be the name of the game object. Okay, let's keep that as it is. Now we can take this, let's duplicate our wall collider, but now we'll call it score. We'll call it score trigger right. I'll go enter. Now let's change this collider quickly. Move it over here. Like this. And now we're going to look in the inspector under our box collider, and we'll say is trigger is true. So that means this is now a trigger and it won't actually stop the ball. And then we will go click on it, Control D to duplicate it. We'll call this score trigger left. And let's move it. Okay, that should do it. Now let's see if that actually works. We'll play. While we're waiting, there we go. Let's check our console. And you can see there, as soon as the ball entered this trigger, we got a message that says, ball just entered score trigger right. I will use this later on when we start having scores for our game. For now, let's move on. Lastly, what we want is a spawn position for our ball so it can actually go back to where it started. So let's say initially we'll just start at the middle of the field each time. Later on, when we've got our player set up, we'll set the ball to actually start from a different place. So let's say here, serialized field, vector 3, spawn position. Okay, now we usually, when we are working with positions, we are going to use vector 3s because Unity wants to know the Z position even though it's 0, and sometimes you can assign a vector 2 to a vector 3 and it will assume that the Z is 0 and just keep it there. But to be safe, we're just going to use a vector 3 for our spawn position, and then we're going to say here, if it enters that trigger or one of the scoring triggers, it's going to go back to the spawn position. So we'll go RB, which is the rigid body, dot transform dot position equals spawn position. This is not the best way to do this, but this will do for now. So here we go. Okay, let's test that. Now if I'm right, the ball should just go back to its start position and keep moving. There we go. Alright, so we've got that. We are currently running almost 30 minutes, so I'm going to cut this off here. In the next video, we will actually start moving around our players so it can hit the ball, and see if we can improve that direction as well, so that player actually hits, or that the ball actually hits sideways. And we might even have time to do a little AI so that we can have a player to play against. Right, until next time, my name is Mani and I make games.